Alright, so today I will talk about particles. And in Houdini 13, they implemented a new particle system. So I think I will split this discussion in two parts. And today we're going to talk about old way, how to do particles and how to work with them. And as usual, we need to create an empty scene. And once we have it, let's create a geometry like this. And yeah, here I have my previous file, which I cached, so looks really nice. Um, but you shouldn't have this. You will not have this. Let's go inside of Geo and delete the file. Well, in your case, it should be just a box. Delete it, and here we can create a particle. So if I type popnet, uh, you can see that I have a pop network, which is a new way, a new particle system, and pop network old, which we're gonna talk about today. So let's create both of them for a moment. And popnet. Okay. And the difference is that old one is a pop network. That's a particle. While the new one is DOP network, which is dynamic operator. And the difference is really huge, and I will cover it on the second part of this lecture. But today I will talk about old way of creating particles. Just a little teaser. Um, Here on the shelf button, on the shelf, we have a shelf button called Fireworks. If I control click on this, this will create a new particle system. And if I play it, you can see that I have little fireworks effect here, which is really nice. And that's possible to do it with all particles also, but yeah, it's better to use a new way. But to understand the particles, we'll start from old one. So, okay, let's create geometry again. Delete everything, create geometry, and create a pop network old. And now let's say show the error, which is fine. And let's dive inside. And that's empty. That's okay for now. And there is two ways to emit particles in PopNet. The first one is source node, and the second is allocation. Okay. The difference is that location is basically a point in the space from which the particles are going to be emitted, while the source allows us to get to emit particles from a surface, from curve, and from any object. And this is a bit more complicated. So let's start with location. Let's activate this and play the animation. And you see that I have particles immediately. There is lots of particles like this. And the first parameter which we see here is coordinates. And that's doing what it says. So it's just coordinate of the point from which the particles are emitted. Like this. Nothing more. Okay, let's move to the birth tab. And here I have an impulse activation, impulse birth rate, constant activation, and constant birth rate. So the main difference is that impulse works with frames, while the constant works with seconds. So I will turn off constant for a moment by setting 0. And impulse birth rate, let's say 5. So once I play 6 frames, I should have 30 particles because 6 multiply 5. And that's correct. I have 30 points. I can turn on numbers, display numbers for each particle here. So I can see where are they. And yeah, I can play more and more will be emitted. Fine. So 6 frames, 30 particles. All right, so if I play rewind and set constant activation to 1 and impulse activation to 0. So in 1 second, I will get 100 particles. So by default, Houdini used 24 frames per second. So I will set 25, hit apply, close. So on frame 25, I should have 100. All right, if you wish, you can calculate, or you can middle click on location, and it's 97. Um, well, that's math, 101. And the birth is not really accurate, so there is little variance. Okay, and well, one particle more, one particle less, nobody cares. Okay, what we also can do and how to control the particles. So I will turn off the constant activation and turn on impulse. And let's say I want to emit just 5 particles. So $F equal 1. So only if this expression is true, my impulse will be 1, like so. Okay, so I emit just 5 particles, and they are flying away and living for very long time. I will make a dark background so it's easier to see. So yeah, the particles just keep flying. Well, the reason is that their life expectancy is really huge. It stands for 100 seconds. So the life expectancy works in seconds, and life variance also works in seconds. So let's set the life expectancy to 2 seconds, like this, and play. So on frame 50, they gonna die, all of them. 50. Wow, that's... Houdini don't want to be precise today. They are dying on frame 53. Okay, which is kind of strange. They should die on frame on frame 50. All right, but I can add more life variants. So some of them will die earlier, some of them will die later. So life variance is 1 second. So theoretically, some of the particles can die on frame 25, and some of them can die on frame 75. Two. Yeah. So let's play, and you see that 2 particles are already dead, and it happened on frame number 57 or something, 60, 70, 75, and 77. So now the particles have the different life expectancy. So this adds a bit more variance to the simulation. All right, next parameter, which is really important. So let's say particles to, let's emit 50 particles. And yeah, okay, let's turn off the impulse activation and turn on constant activation. So like this. On frame 25, I will have around 100 particles, right? And let's say I want to have control about the particles which just has been created. And to do this, we have a birth group, and let's call it new particles. Now I have a typo here. New particles, and let's rewind, and you can see that I have a point groups. Middle mouse button click on node, and I have 4 points in new particles. Okay, let's play a bit. So now I have 68 points and still only 4 points in new particles. Why it happens? Well, the reason is that by default this group contains only just born particles. So each frame it emits some set of particles, and let's say 4. Well, it looks like it's emitting 4 particles. Yeah, 4 particles. So that's why it's always 4 in this group. If I want to add particles into this group, I need to click on the checkbox Preserve Group. So currently I have 4 particles. On frame 2 I have 8 particles, and 8 particles in at all. So now the full number of particles and particles in group are equal. Alright, so let's turn it off and let's leave it here. Next tab, which is called attributes. Here I can add velocity to my particles. So currently the particles flying away in all the directions because there is no direction for them. But let's say I add some velocity into particles. So now they're moving all in one direction. So you see I can control it like so. And again, this is a vector math. So it's controlled by vector. Okay, let's bring it to default. And let's say I have velocity in one direction, in x, like this. But all of my particles have the same velocity, so they're moving really even, and that's not interesting. What I can do is add some variance to the velocity again. So let's say variance. No, oh, okay. By default, it has variance 1, but if I set it to 0, then my particles will move like this. Yeah. So now they even and boring. All right. So let's add more variance. And now it's only in one axis. Let's add a bit more in 2. But you see it's flat. So it moves only, there's a variance only into axis. So now I'm adding in all 3. Yeah. So that's a simple way how you can control your particles. But this is very primitive and simple control. So let's stop the animation. Um, let's bring it to default. Alright, so particles are flying away. Uh, what if you want to emit particles from surface? Well, in that case, you have to use a source node instead of location. So let's delete the location node, and here we have a source one. Well, by default, it has an error, cannot obtain the geometry of the specified sub. Well, sure, because there is no geometry connected into this node. There is two ways how you can add this. Well, there is more ways, but two of them are most obvious. You can attach the surface into this field. Well, currently I have no surface, so let's first let's save. Let's save it. All right. So I saved my scene to proper place, and uh, oh yeah, now I need to create a geometry. Okay, let's rewind. And by default, this button here stands create at object level like this. So your icon here should be like this. And as you remember, if I click Control on sphere now, this will create a sphere on scene level, which is not correct. Well, that's correct, but that's not what we need. So let's delete the sphere, dive inside of the geo, and let's change this icon to create in context. So the icon will look like this. Now if I create the sphere, this will be created inside of the geometry node on the same level with PopNet. Okay, and now if I connect my sphere to PopNet and dive inside, the error is still here. Well, the reason is that my geometry source, which is stand here, has few options. Use parameter value, which is this, so I can set my sphere here, and now it appears here. Or I can use first context geometry, which is, by my opinion, in that case better because I can decide to keep my pop network but change my emitter geometry. Well, I can do it manually and connect new geometry, but instead, let's say I have also a cube here, a box. Let's drop a switch node. All right. So let's say I want to switch from sphere to cube and emit from cube. If I use a context geometry, then it will automatically update my source, which is more comfortable, I guess. All right, so let's go back to sphere and dive inside of PopNet. If I play animation now, let's turn on numbers on points so you can see them. You see that particles are emitted, but they are not flying away, and they are emitted from the center of the sphere. Well, that's correct because they emitted in the center because my sphere is primitive, and the primitive has only one point in the center of itself. To get more points, I need to switch to polygon, and now I have more vertex to emit from. And if I dive back, you see that particles are emitting from each vertex of the sphere. But again, they're staying on the same place. Well, the reason is that by default there is no velocity, and since there is no velocity, they is staying on the same place. Well, there is few ways how you can add velocity, and let's start from simplest one. So you need to go to attributes, and here we have initial velocity. Use inherited velocity. You can add to inherited and set initial. Well, by default it stands inherited, and there is nothing to inherit from. So let's add to inherited. If I play now, the particles will start fly away. Well, the reason is, even if I have zero velocity, I have a little variance here. And that's why they started flying away. If I set it to zero, like this, they will stay in the same place. Alright, so let's bring it back to a little variance. So the particles start moving and flying away. Alright. And again, I can add some velocity, so they will move on a specific direction, like this. That's the one way how to do this. Okay, let's bring it to default. But what if you want to use inherited velocity, like this? Well, particles in Houdini, by default, they use a normal as a vector. So if I put normals to each vertex, this will be used as a vector force, as a velocity for the particles. And to do this, I need to create a point. I'm not sure if you see this, but this must be a point operator. And let's drop it between sphere and PopNet. Okay, let's do it like this. Just turn off this part for a moment. All right. So that's how it looks: sphere, point, PopNet. In the point, you can go to particles, and you can add velocity here. Delete channel, set velocity to 1, and play. Alright, so the particles are emitting now, really even. Or you can add normal. So let's say you turn off velocity here, and in standard, you're adding a normal. And you see these vectors here. They are showing the normal. So yeah, so now the particles will move in this direction. So yeah, so that's how you can add the velocity to inherit from. Well, that's not the ways how you can control it, but for now, let's leave it like this. So, okay, I will, uh, yeah, okay, I will leave it like this. Yeah, particles are flying. Let's dive back to PopNet. And here we have inherit velocity 1. This is just a multiplier for inherited velocity. So you see I can multiply it, and this will be faster. Yep. Okay. Let's by some reason it's not updating sometimes. Okay, but you see that animation is pretty boring. The particles are flying and they're pretty even. So what we can do is add a bit noise. And to do this, we have a few ways. And let's start from force. Attach the force to our source. And let's play. Well, not much happened, but probably it's possible to see that particles are just wiggling a bit. To make it more dramatic, more visible. So I put a bit more amplitude and you see that it become really wild and uncontrollable. So it's a noise which is applied to the particles and they're flying away. So it looks pretty nice. Alright, to add a bit more randomness, you can add offset. But to adding offset to all of them like this will bring not much difference. Instead, you can add random. Let's say rand $ID, where ID is particle number. Uh, Something like this, for example. So now particles flying really differently. And you can do it for each axis. Something like this. Alright. But the thing is that this force is keep applied to the particles constantly. And let's say I want to apply it only for new particles. Well, that's where we can find the birth group useful. So let's create a new particles group, new particles, and let's not preserve it. Let's say some life expectancy 3, life variance 1, and maybe a bit more particles, like this. So now particles are dying really early, and I forgot to apply a source group, new particles. So now the force must be applied only for new particles. And you see the behavior is changed. Well, now I need to apply more, something like this. So now the particles receive the initial impulse and keep flying once they emit it. They get the force and keep flying. Yeah. And currently they're flying away without any air resistance. So there is no stopping force. Well, there is easy to fix it. And let's create a drag force. Drag force emitting the air density. So like in real life we have some density in air, and if you move really fast on your uh, oh, the car without roof, cabriolet, or yeah, convertible. I forgot this word. You move really fast on your convertible, you should feel the air coming to your face. So that's the drag force. All right, let's apply it currently to all the particles. And you see that the particles are like stacking like in a gel. All right, let's apply it on the 4 new particles. Like this. And maybe increase the scale. so they're not flying away really fast in the beginning. Drag force. Yeah. So that's how the drag force works. Um, in the force node, there is actually force tab, which is also can add some force to the particles. Like so. So all of them are moving on the same direction. And let's add some turbulence. Let's add some amplitude, maybe frequency. And drag force is probably too huge. And maybe force too huge. Well, that's as usual. You need to search the numbers. So yeah, now we have the direction. The particles are dragged by air field, and they're just moving. All right, that's the one way how you can add noise to the particles. The other way is a VOP. VOP, VOP. Well, the naming here is really funny. VOP, VOP. I don't know. That's okay. Uh, it's almost like VOPSOP, but only for particles. And I will talk about this on next lectures. But currently, let's create a VOP, activate this, and dive inside. And here we have a global and output. This is a global variable which is accessible from any place. And what we can do is we can create a noise. And let's create a Carl noise. So here we have a bunch of parameters, and currently we need we need a point position, which is vector, and we need to attach it to position of the noise. All right, and next we want to add this noise to position of the point. So add is a keyword. So I need to add this node and attach it to this. So like so. So currently my each point from from here will be transferred into Carl noise. The mathematical operation will happen here, and I will get the result, which is will be added to default value of the point. And then some should be applied to point. And let's promote all the parameters to higher level, so we don't need to go inside of WOP each time. All right, I will show you. So currently, if I go up, well, this shouldn't be here. Well, it's here because I promoted it. All right, so create input parameters, and this is locked. So now I can control my Carl noise from particle level. All right, so let's play it. And you see that particles moving like this. Well, uh, yeah. And this looks not really nice. What we can do is we can go up, and in a PopNet there is an oversampling field. The oversampling is basically like a substep for dynamics, so let's add a bit more and play. Well, a bit better, but still. So now the particles are visualizing the noise. This is like a 3D noise, and Perlin, let's change it to original Perlin, like this. So you can see how the different noise parameters working. Alligator, simplex. Alright, you can play with it. So that's two different ways how to add a noise. Well, there is one more, which is affect by volume. Okay, I will save the scene for now, and let's create affect by volumes. All right, this is a bit more advanced, but this offer more. So let's create this and play. Nothing happens now because there is no velocity again. And to add this velocity, I need to go one level up, and let's create box like this. Well, just let's make it a bit bigger, like this, and convert it to volume. So, and we need to create a velocity field. So the volume, the rank should be changed to vector and call it vel, not the capital, just vel, and set initial value to 1. This should look like a fog now. We can change the resolution. So the higher resolution, the higher the quality of the simulation. Alright. And now I can apply the VOP sub. So that sounds familiar. Volume VOP. And let's do the same. So just, well, almost the same. Let's add noise. The same Carl noise, for example. Same operation. But currently, I will not add it to initial position. I will but I will import it, excuse me, export it as a parameter. So as val parameter. So I need to create a parameter and call it val. All right, and this should be 3 floats vector, and change export to always and set invisible. All right, so now let's add this noise, and you see that the fog inside of the box is changed. Well, the reason is that we applied the noise. You can visualize this noise by creating a volume trail, and this must be a velocity volumes, and here points to trails. So let's create a grid, for example. Yeah, let's make this grid like this. Maybe a bit more rows for resolution. So this node, volume trail, is visualize the velocity field. Well, velocity, yeah. All right. But nothing happens now, and that's correct. Well, I just forgot to promote my parameters, so I can control it from here. All right, and let's animate offset $f multiply 10, for example. So now if I play the animation, this will, well, something like this. This will animate my velocity field, and in volume trail, I can control the length, not length, but the visualization, and trail length is here. Yeah, something like this. Well, this is for just for visualization and to make things easier to understand what's going on. All right, so I have animation, and now I need to apply this velocity field to my popnet. That's what I'm doing. I connect uh, my volume pop into second input, activate my popnet, and dive inside. All right, so here in add vect by volumes, I need to set my velocity volume, which is uh, well, naming. I should name it. So let's create a null and call it outval, something like this. So now I can easily understand how it's named and what I need to select here. Outval, accept, and let's apply this. So now my particles are affected by velocity, but you see that this is a slow, uh, well, kind of hard to calculate way, and probably my oversampling was too high. So yeah, now you see that particles are moving and controlled by this noise. And this looks really interesting, and this can create some nice effect. And here is few options. Treat as wind. So, and all of this can, well, okay, number of threads. I wonder if I set number 8 threads and oversampling to something high, how this will handle my simulation. Well, not really, not really nice, but okay, that's fine. So let's bring oversampling to 1. Okay, so that's a 3 different way of controlling the velocity. Well, that's really, really nice. Okay, um, let's see more parameters which particles have. So I will go back to simple way, deactivate all of this. All right. So now I have just source, which is applying force, and drag it. Yep, like this. If you switch to details view, here is a whole set of parameters, and we have point position, acceleration, backtrack, ID, life. Uh, so the life is saying how old the particle, velocity, and normal. But currently we have no speed. So let's add speed parameter, speed attribute in source. And now I have speed field. So you see that the speed field is really different. And what if I want to control the speed of my particles? Well, there is a simple way to do this. There is a node called a speed limit. Let's connect it after the drag. And let's check my particle speed for now is somewhere between 0.5 and 3.14. So let's say I want to set my speed limit from 0.8 to 2, something like this. Oops, I forgot to activate this. So now you see that the speed is controlled by this node. So I don't have a speed above 2 and I don't have a speed under the 0.8. And if I set minimal speed to 10 and maximum to 15, this will like resample, uh, re change the range of the speed. Alright, so one more example about how to add noise to particles is adding a Carl noise node. So it's doing basically the same like in WOP pop, but this just on this level. So you have control about all your noise parameters. So let's play this. So something like that, and absolutely the same parameters like in a WOP pop Carl noise. So it's the same. All right, so that's all about adding noise.